1.3 Composite functions. When one function is followed by another function, the resulting function is called a composite function. Given f of x and g of x, the composite function of f and g is represented by fg. It means f following g. Here we have three sets: set x, set y, and set z. Function g convert x into y, and function f convert y into z. Instead of doing function g and f separately to obtain z from x, we have a composite function called fg that can directly convert x into z. Note that f of gx is not equal to g of fx. The sequence of which function need to do first is important. F square x or f of fx is not equal to the function fx square itself. Let's look at the example 1.3.1. The function f and g are defined by function f such that x is converted into 1 minus 3x and function g such that x is converted into x over 2. Find the composite function of the following. Here we have two pieces of information, fx and gx. F of x is equal to 1 minus 3x and g of x is equal to x over 2. Here I change the color of the variable so that we can see the difference clearer. The first one, we are asked to find f of gx. Here, gx is our variable. We substitute gx into the function f, we get 1 minus 3 gx. 1 minus 3, what is our gx? Our gx is x over 2. Substitute into our function. Then simplify it, we get our f of gx. Second part, we are asked to find g of fx. We have g fx. Fx is our variable. We are substituting the fx into the g. Gx is equal to x over 2. Therefore, g fx, we will have fx over 2. Substitute the fx, 1 minus 3x over 2. And the third one, we are asked to find f of fx. F square x, which is f of fx. Substituting fx into function f, we will get 1 minus 3 fx. We get 1 minus 3, 1 minus 3x. Expand it. We have 1 minus 3. Minus and minus, we get a positive 9x. Simplify it, we have 9x minus 2. And the fourth one, we are asked to find g square x, which means g into g. gx. Gx is x over 2. Therefore, ggx will be gx over 2. Substitute the gx, x over 2 over 2, which is x over 2 multiplied with 1 over 2, we get x over 4. Lastly, fg square x. Fg square x meaning putting fg into fg. The function fg, we already obtained it in the first part, so we need to use that piece of information to continue our working. fgx is 1 minus 3x over 2. So fg of fgx will equal to 1 minus 3 fgx over 2. Substitute it again, we get 1 minus 3, 1 minus 3x over 2 over 2. Let's expand it. We have 1 minus 3 plus 9x over 2 over 2. And we get negative 2 over 2, add with 9x over 2, multiply with 1 over 2, negative 1 plus 9x over 4. Or maybe we can rearrange it, 9x over 4 minus 1. Example 1.3.2. Two functions f and g are defined by function f such that x is converted into 3x plus 4 and function g such that x is converted into x squared plus 6. Find the expression for fg and gf. Then find the values of x when f equal to g and fg equal to gf. So here we have two pieces of information, fx and gx. We are asked to find fg and gf before finding the value of x. Fx is equal to 3x plus 4. Gx is equal to x squared plus 6. Let me change the color. X is our variable for f and g. First, we need to find f of gx. So substitute the gx into the function f. We get 3gx plus 4. Again, what is our gx? X squared plus 6 plus 4. Expand the bracket. We get 3x squared plus 18 plus 4. Simplify it, we have 3x squared plus 22. The next one, we are asked to find g of fx. G of fx. Substitute the fx into the function g. We get fx squared plus 6. What is our fx? 3x plus 4 square plus 6. Expand the bracket. We have 9x squared plus 24x plus 16 plus 6. Simplify it. We have 9x squared plus 24x plus 22. The first one, find the values of x when f equal to g. F of x is equal to g of x. Fx is 3x plus 4 is equal to x squared plus 6. Since at the right side I have a positive x squared, I'm going to move all the terms at the left side to the right side. X squared minus 3x plus 6 minus 4 equal to 0. Simplify it, x squared minus 3x plus 2 equal to 0. Then we factorize it. X squared is separated into x and x. 2 is separate into 2 and 1. Here we have 2x. Here we have 1x. 2x and 1x, we are able to get 3x or 1x. We need to get a negative 3x. This is the combination we need. To get negative 3, we need to have negative 2x, negative x. And lastly, we need to check negative and negative. We will get a positive over here. X minus 2 is equal to 0. x equal to 2, or x minus 1 equal to 0, x equal to 1. For the second part, find the value of x when fg equal to gf. Fgx equal to gfx. What is our fgx? We have 3x squared plus 22 equal to 9x squared plus 24x plus 22. This is a quadratic equation. On the right side, I have a bigger value for our x squared. I'm going to move everything to the right side so that I get a positive x squared. 9x squared minus 3x squared plus 24x plus 22 minus 22 equal to 0. Simplify it, we have 6x squared plus 24x equal to 0. Factorize it. We take out the common factor, which is a 6x. And what is left in the bracket? For the first term, we left with an x. And the second term, we left with a 4. 6x is equal to 0. X is equal to 0, or x plus 4 equal to 0. X equal to negative 4. Example 1.3.3. If function f such that x is converted into x minus 1 and function g such that x is converted into x squared minus 3x plus 4, find the following. We have f of x equal to x minus 1 and also g of x equal to x squared minus 3x plus 4. X is our variable. Find f of g2 and g of f1. For this kind of questions, we have two ways of solving it. I will show you the two methods. Method 1, find a general function for fg. First, we need to find a general function of fg, f of gx. Substituting the gx into the function f, we have x squared minus 3x plus 4 minus 1, which is x squared minus 3x plus 3. This is our fgx. To find fg2, we just change the x into 2. We get 2 squared minus 3 times 2 plus 3. 4 minus 6 plus 3, 1. The second method is to find the value of g2 first. G of 2 is equal to 2 squared minus 3 times 2 plus 4. We get 4 minus 6 plus 4. We get a 2. Then we find the value of function f of g2. The same as f of 2. Substitute the 2 into our function f. We get 2 minus 1, 1. By using both methods, we will obtain the same answer. However, method 1 has more advantage because we are finding a general function, which means we can always reuse the function to find different solution for different x value. But for the second method, it's a very specific question, so we can only obtain the answer for that particular questions. Next one, we are going to find the value of gf1. For this, I'm going to use the method 1, find a general function for gf. G of fx is equal to fx squared minus 3 fx plus 4. Substituting fx into the function, x minus 1 square minus 3x minus 1 plus 4. Expand the bracket, we get x squared minus 2x plus 1. Negative, positive, we get negative 3x. Negative, negative, we get positive 3 plus 4. Collect all the like terms together, we have x squared, negative 2x minus 3x, negative 5x. And all the numbers, 1 plus 3 plus 4. So we get a positive 8. To get g of f1, substituting the 1 into the x, we get 1 squared minus 5 times 1 plus 8. 1 minus 5 plus 8, 4. For the second part, we are asked to find the values of x when f gx equal to 7. We have a hint here, find the values of x, so later on we'll get more than one answer. F gx equal to 7. We already obtained a general formula for f gx, which is this. X squared minus 3x plus 3 equal to 7. This is the advantage of getting a general function for composite function. This is a quadratic equation. Let's solve it. X squared minus 3x plus 3 minus 7 equal to 0. X squared minus 3x minus 4 equal to 0. X squared is separate into x and x. 4 is either 1 and 4 or 2 and 2. Example, if we put 2 and 2, we will get 2x and also 2x. But 2x and 2x, we can only obtain a 4x if we add them or we get a 0x. Here, we need a negative 3. So this is not the combination we want. So let's try 1 and 4. Here we have 4x, 1x. If we add them, we will get 5x. If we minus them, we'll get 3x. This is the combination we want. We need to get a negative 3. In order to get a negative 3, we need to have a negative 4 plus 1. And lastly, don't forget to check positive, negative, we get a negative here. X plus 1 equal to 0, x equals to negative 1, or x minus 4 equal to 0, x equal to 4. So we have two values of x. Example 1.3.4. The function f is defined by function f such that x is converted into 2x plus 5. Find function g if fg and gf are given as below. Our purpose is to find the function g. And we are given a composite function and also the function f. We have two cases here. First one, the function g is inside, and the second one, the function g is outside. Let's look at the first one. F gx equal to 13 minus 2x. How are we going to solve it? F of gx equal to 13 minus 2x. Let's look at our function f. X is the variable. For this one, they are substituting the gx into the f. So since we already have the function f, this is easier to do. What we do is substitute the g into the x. So we have 2 gx plus 5. So let me make it clearer. is equal to 13 minus 2x. We already have our gx here. What we need to do is to solve the equation. First, we bring the 5 to the other side. 2gx equal to 13 minus 2x minus 5, which is 8 minus 2x. Then we bring the 2 over, become divide, so gx will be 8 minus 2x over 2. Gx is equal to 4 minus x. For the second case, the gx is the outside. We have g of fx equals to negative 1 minus 2x. But however, we do not have the function g. What can we do is we substitute the fx instead. The next step is we have to make the object or the variable into one singular variable. This is a side working. Let y equal to 2x plus 5. Then we make x the subject. Y minus 5 is equal to 2x. X equal to y minus 5 over 2. This information will be useful later on. Continue for our g. Now we already know 2x plus 5, we let it be a y. So we have g of y equal to negative 1 minus 2. Since we already make the object into y, we have to change the x into y. What is our x? Y minus 5 over 2. Then simplify the equation, we get negative 1. Expand it. Minus y plus 5. We have 4 minus y. This is our gy. You can stop here or you can change the y back to x. Gx equal to 4 minus x. So this is the method to obtain a function from a composite function and a given function. For the next section, we will discuss more questions on composite functions. You may try the questions and see how much you understand about this topic. In the next video, a detailed solution will be given. So good luck in trying the questions. See you again in the next video.